In this video, we'll try to get to parts B and C since they're both somewhat related here. In B, we're going to write the first four non-zero terms of the Taylor series for cosine of x about x equals 0. Again, that's pretty straightforward. For B, we have cosine of x, and again, we write is approximately equal to 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus x to the sixth over 6 factorial. Now, we want to use this series and the series for sine of x squared that we found in part A to write the first four non-zero terms of the Taylor series for f about x equals 0. And you recall that f is simply sine of x squared plus cosine of x. So if I bring down a copy of, well, right here, a copy of sine of quantity x squared. Okay, so we have that there. Now, we want to also then write the first four non-zero terms of the Taylor series for f, which is sine of x squared plus cosine of x. Alright, so the first one is definitely the 1 that we see there. Now next we have an issue. So the 1 is gone. Next we have two x squared terms. So we have to watch out for that. And they do not comprise two separate terms here. So that's another thing that you have to look out for. So we have an x squared minus an x squared over 2 factorial. And together, these are going to make up the second non-zero term. Then for the third term, we simply have 1 x to the fourth, which would be x to the fourth over 4 factorial. But for the fourth term, again, we have an x to the sixth, a negative x to the sixth over 6 factorial, and a negative x to the sixth over 3 factorial. So negative x to the sixth over 6 factorial minus x to the sixth over 3 factorial. And once again, together, these will comprise the fourth term. So remember that just because you have individual terms there, as long as they're like terms, we have to combine them together to make a single term out of them. So the first one is not too difficult. We have 1 plus x squared minus x squared over 2, a whole minus a half, leaves us with a half x squared over 2 factorial. And the third term, likewise, is pretty straightforward. Now, the difficult part here, obviously, is going to be finding a single term for this, for the last two parts there. So, x, they're both negative, but x to the sixth over, and it's negative, 6 factorial. 6 factorial is 720, and 3 factorial is 6. So we're going to need to multiply top and bottom here by 120 over 120. And we end up with negative 1 over 720x to the sixth minus 120. So our final answer there is negative 121 over 720x to the sixth. And I'll write that in here. It's a minus 121 x to the sixth over 720. And so that does it for part B. In part C, we're asked to find the value of what is the sixth derivative of f at 0. Well, we could take the sixth derivative of sine of quantity x squared plus cosine x, doing the first, second, third, fourth, fifth, sixth, etc. That's going to take you a while to do that. You should recall that each term of a Taylor series each term of a Taylor series is really the nth derivative, in this case a Maclaurin series at 0, over n factorial times x to the nth power. So if we're looking for the value of the sixth derivative, in this case we're looking for the sixth term, sorry, the x to the sixth, the term for x to the sixth would be the sixth derivative about 0 times x to the sixth all over 6 factorial. And that is this term, the x to the sixth term in the series above. So all we need to do here is write that the term, the sixth derivative at 0 times x to the sixth over 6 factorial is negative 121 x to the sixth over 720. And fortunately, since 720 is 6 factorial, and the x to the sixth's cancel out, and we have simply that the sixth derivative of f at 0 is equal to negative 121. And so that is the answer for part C. No big deal there. So we'll go on to part D in the next video. Now this idea here is very important. Somewhere in the test you will be asked to identify either the coefficient of x to the sixth or the sixth derivative of f at 0. And you have to be able to put together this type of an equation and isolate just the derivative from that. So this is a very important process. Make sure you understand what happened here and you see the logic and the reasoning behind it. If you do, it actually was not a difficult problem at all.